the session. To all that, to those that don't know me, my name is Ahmed Jassat. I'm working at Entity as the operational manager, but very fortunately, I've been approved and awarded to be part of the Oracle ACE program. The Oracle ACE is a unique program where subject matter experts work proactively with Oracle product development in testing Oracle software and, of course, learning of new technologies, which we can demonstrate and advise our clients as well. So today we are extremely fortunate. On the call we have with us, just to introduce you, Kavi Beesoon. Kavi is a member of the Oracle ODA team as well, and one of Oracle's advisors. Then we have Matteo, who's going to be part of presenting through to us. And as well Corrado, who's a developer at Oracle as well. So what we're going to be discussing is the Oracle database operator for Kubernetes and Spring Boot backend as a service. To the Entity team, we're going to be planning monthly sessions with Oracle product development that gives us an opportunity to learn from the people who develop and engineer these products, so that we can go out to the market and give our customers the premium service as well. So every month you will be receiving an invitation from me. Please try to join these sessions so that they can add value to you and your customers as well. That's all from me now. Kavi, you want to take over now?
Yes, thank you, Ahmed. So I think this will be a very enriching sessions that we're going to present. And Corrado will be starting with Spring Boot, right, on the Kubernetes environment. And then later on, if Matteo will join us, then we'll cover the Kubernetes part. I don't know. I'm not able to get hold of Matteo right now, but we can still start, like I said. So I'll just over to you, Corrado. Thank you for accepting to do this, and thanks so much.
Okay, thank you. And good morning to everybody. Can you see my screen, my first slide?
Yes, we can see it.
Oh, perfect. Okay. In my seminar, we will see how we have embraced the containers, operators, and the Kubernetes in order to simplify as much as possible the deployment of the Spring Boot application, leveraging the Oracle database converged. Let me introduce briefly myself. I'm in the development team of database. I'm based in Italy. And my team is in charge of microservices and messaging platform development. And we have developed this platform that I'm going to show to you. First of all, let's talk about the topic of a backend platform in general, in order to introduce the reason why we have developed this platform and that is available to you. Backend as a service is an approach coming from the 12 patterns defined for building microservices. This pattern suggests to you how to approach a microservices in general project, and one of these
sorry, Corrado, you've gone on mute. You muted on your side. Oh, you came off mute and you went back. Yeah, now you're on off.
Okay, can you hear me?
Yeah, we can hear you clearly, yes.
Okay, sorry. Okay, let me talk again about this topic. We are going to talk about a backend platform and how it helps developers in general to in the development of a microservices project. This backend comes from one of the 12 patterns that have been defined in order to simplify as much as possible and to be success in a microservices project. The backend as a service offer to you the capability to simplify as much as possible the development and the deployment of a microservices application. For these reasons, we have developed the Oracle backend for Spring Boot and microservices in order to make super easy to develop and deploy a Spring Boot application and mobile services, leveraging the power of Oracle Converged Database. Why? Because in a modern application backend stack, we have three key parts. One is containers, the other is Kubernetes, and of course the database. This platform tried to unify the offering, embracing containers, Kubernetes, the operator that my colleagues will talk later, and the database platform in order to simplify and embrace all the technology that you need to be successful on microservice deployment and management day by day. We have also included in this platform component that you can leverage to simplify the development and the management of your application. For example, microtics that I'm going to talk about later. And also you find inside the Converged Database the support for an async message layer to guarantee transaction alternative to Kafka as a messaging layer. First of all, where we can get this platform, the smoothest way is from OCI Marketplace, because we have provided this platform on OCI, on-premise, eventually also on Azure. And first of all, let me say that it's completely free in terms of licensing, because we offer as a platform in a community edition way, and the only fee that you will pay is about the consumption on Oracle Cloud. For this platform, we deliver after the process of provisioning one autonomous database with 2 OCPU and 3 compute nodes for managed Kubernetes cluster. In 20 minutes, on-premise, on OCI, or eventually Azure, you can have all the components that you need to deploy your application built on top of Spring Boot framework, like a Kubernetes cluster, Spring Boot services, an API gateway inside the Kubernetes cluster, a transaction manager to manage your microservice in transaction way, so to have a three-phase commit orchestration, a classic orchestrator, a mobile backend, compiler services for GraalVM, the operator already installed configured inside the Kubernetes cluster, and obviously the Oracle database. So, and many more services that, but I don't want to go too much in depth in terms of microservices that we deploy with the provisioning. These are the most important service that you will find installed and configured ready to run on Kubernetes at the end of the provisioning process that you can accomplish in 20 minutes. First of all, the main services that normally the developer needs when they deploy a Spring Boot microservice project. I'm talking about the service registry Eureka, the admin dashboard, and the Spring Config server that collect all the metadata that you need to share between microservices in a central point. To open your microservices that are inside a Kubernetes cluster, you will use an Apache 6 API gateway. This is an open source API gateway, in order to have your application more secure, because without this routing that you can do through a console in API gateway, you can't have access to any service that you deploy on Kubernetes cluster. In terms of observability, we have already deployed in this platform what you need to observe your application through open source common application like Prometheus, Grafana, OpenTelemetry, and Jaeger. The security stuff the credentials are managed through HashiCorp Vault, leveraging the OCI service. And in terms of orchestration between microservices, you can leverage another open source product named Netflix Conductor that comes from Netflix. In the middle, you can see that we have also GraalVM as a service to compile your application in a native mode to make it there more quicker and cheap in terms of consumption. And MikroTix to orchestrate transaction distributed between microservices. On the right corner, up corner, you can see that we have also the support for mobile application that we have included through an open source platform coming from Facebook named Parse that you can leverage to open your microservices to mobile client in an easy way. How it's complex to move your existing Spring Boot application to this platform is quite easy. It's explained in this tutorial. It takes 5 minutes. You have simply go to your project, customize some entry in your project, and build your jar file that can be deployed in the cluster through command line utilities that we have developed and a VS Code extension that you can use too. It's this command line utility that simplifies the deployment of microservice allow to you, without any experience on Kubernetes, to deploy and manage your Spring Boot microservice on this backend platform. This command line creates for you the application namespace to include a subset of your application of your microservice in a managed area. Create for you the schema that your application will leverage to provide the data on Oracle database, and store all the secrets needed to access the database. So you you can't have access to database because through this command line, you can have all you need for deploy your application. You can compile your application through GraalVM to make your application faster than the normal jar file. And also, you have the utility to deploy your microservice. Normally, you have to create a container image, push to container registry, create deployment descriptor, and so on. Everything is done for you through this command line with just one command that provide all the information and create all the artifacts needed to be deployed and run inside this platform. And finally, you have also the opportunity to configure all you need for your application in terms of metadata that have to be shared through several microservices that you have deployed. And you can use this command line to do everything. So in terms of who develop, you have everything easily to access to the cluster and manage this. In terms of deployment, the cluster is you can access and modify as you want. So you are free to use our command line utility, but you can also use kubectl, the classical Kubernetes command line, if you want to make customization in this platform. The same you can do through the Visual Studio Code extension that we have developed that is available. You can plug this extension in your Visual Studio Code and you have an access point and click to the platform. So you can list the application and the single microservice inside. You can open the console through to the single vertical service that we offer to manage as platform services your environment. And you can also configure the metadata through the application. For this and the previous command line is available to video on YouTube. So when I provide to you the slide, you can see by yourself how you can work with these utilities that we offer to manage the Oracle backend. GraalVM is our virtual machine that provides to you the capability to compile the jar file application in order to make native in the target environment. We have included this utility inside the cluster in order to save RAM in terms of execution, make your Spring Boot application much more quicker in terms of startup, and also in running, and reduce of 40% the size of images that you have to store in the registry server. Since that GraalVM should be done on a target platform, we offer a service that allows you to upload your file, jar file, compile it on the cluster, and run as a normal Spring Boot application. Since Spring Boot app from the release 3.0 is certified to be compiled on GraalVM and make it quicker than the past. Another important stuff that we have introduced and is available to you at the end of provisioning is the Oracle Transaction Manager for Microservice. The code name is MicroTX. This offers to you a transaction manager coordinator among microservices built on REST endpoint. You can do by yourself this kind of implementation, but it's quite complex to do. Through this coordinator, you can have a transaction initiator, an application, a microservice that need to start a transaction between several components, several microservices. And the coordinator guarantees to you the two-phase commit or long-running action coordinator or try and confirm way to manage a distributed transaction. This is available as a product, as the operator that we will talk about later. But we have introduced and make available to you already configured in this environment to make it easy to use it and run with your application. At the end, don't forget that the Oracle database provides to you also a broker for high scalable messaging platform that is designed as Kafka, so you can have your producer, your consumer exchange messaging through this platform that is inside your Oracle database and scale with the database, and you can backup the data through the normal utilities that are provided with Oracle Autonomous Database and also on-premises release. This layer so can offer the messaging platform for producer in any kind of language. In this case, we are on a Java platform, Spring Boot Java, so we will use the Java, but we can also have other kind of clients. And you can create also an architecture in which you have several remote database environment that propagate the messages through them, and have a remote consumer that consume the same message that you distribute in several environment and remote environment. And finally, you can also exchange messages through a Kafka connector to an existing Kafka cluster and a Kafka client. At the end, let me talk briefly about the support for mobile application that we have introduced in this platform that is ready to be used. It comes from Facebook that has open sourced years ago, and offer to you, to the mobile client, several SDK for Android, iOS, and other technologies that allow to you to leverage these topic services like query, file management, and everything run on top of JavaScript Express backend. And we have introduced an Oracle adapter in order to have the data inside the Oracle database. And we have also delivered in open source this adapter. It's available to you. And all data coming from the file topic API will be stored inside object storage because we have also introduced a support for OCI object storage. In terms of practice on this platform, how you can learn to use this platform, it's quite easy because we offer not only the common documentation that you will find online, but we have provided to our customer a full lab that is available on Oracle Live Labs. The name is Cloud Bank. Through this lab, you can be driven in the usage of the platform from scratch, starting from the deployment of this platform, step by step, create an application of this kind with several microservices, leveraging also transaction, distributed transaction. And we, at the end, create a mobile application that consumes these services that we have developed inside this platform. So I invite you, if you want to understand better this platform, to leverage this Oracle Live Lab, and eventually we can provide to you a workshop on demand to simplify the use of this platform through this Oracle Live Lab that is available online. So let me summarize the main topics that have been shown in this seminar. First of all, this is a deployment platform for Spring Boot. So if you use a Spring Boot framework and you want to deploy easily this platform in a managed cloud native environment, you can leverage this platform. We have inside this platform also the mobile backend support in order to expose your services Spring Boot through a platform to mobile terminal that needs particular services to run through SDK. We have tried to unify the application Kubernetes database to make app dev simple. The reason why is this platform comes from an internal request from our vertical application that need to simplify. We have decided to offer this platform to our customer too. This platform is not represent a cloud lock-in, so you can run on-premise OCI on Azure. You are free to use wherever you want, and it's also free of charge. So for you, no additional charge. At the end of the day, if you want to deploy a Kubernetes application, we will pay for Kubernetes and Oracle database. This is on top to simplify the development and the deployment of this kind of application if you use Spring Boot microservice. It's available community edition, and in terms of POC demo and training, I've shown to you that are available not only documentation but also a full live lab that you can use to train by yourself or with our guide. So I think that I'm time. I have finished the presentation. If you have any question, otherwise I go over with my colleagues on the next presentation.
Thank you, Corrado. Thank you so much.
You're welcome.
So maybe we have another 5 minutes that we can use for questions. Ahmed, anything? I don't see anything in the chat, so.
Hi team, any questions, guys? We want to make it informal, so you're welcome to put questions in the chat or to raise your hands. Any questions for that? So Corrado, we have a lot of financial institutes which we service, you know, on the database and the managed services side, you know.
Yeah.
How can Spring Boot assist us with our ERPs? Because we have some ERPs as well, you know, EBS suite, the Oracle database, and, you know, some of them use Apex. What would be the benefit of, I mean, I see the benefit in developing a mobile app, you know, so we can go in and develop, you know, as quick as, you know, very extremely quickly. So we provide the solutions, but customers that are already using Oracle core technologies, how would we, you know, add or benefit to that?
They can customize and add new services through Spring Boot in general, but we have been planning also to move some of this application natively on this Spring Boot backend in order to make cloud native and based on microservices the core of this of some of these applications. Will be announced this year. It's not yet official, but we have been planned to move some of our vertical on this platform that we have introduced for the final customer, but also for inside use as a chassis on which plug our application.
Thank you very much. Thank you. I mean, I can see benefits where we can create apps, you know, for a number of things in the organizations, you know, registration to conferences, you know, I'm just thinking of that, you know, we can use it for schools if you want to give back to the community, CSI projects, you know, things like that. Thank you very much, Corrado, and thanks for giving us your time on that. So Team Corrado is from product development. Do go to LinkedIn and connect with Corrado. And these are the networks that we are trying to build. Next, we have Matteo. Matteo will be speaking to us about Kubernetes. Good morning, Matteo. How are you keeping? Sorry, you're on mute.
Matteo.
Okay, can you hear me?
Okay, now.
Yeah, no, we can hear you loud and clear.
Okay. Hope loud and clear, because yesterday I had a couple of problems with my microphone. Okay, let me share the screen. Can you see the screen?
Yes, we can see this. It is coming up. It is coming up. I think you just need to check your display settings. We're seeing the middle half of the screen.
Yeah, Matteo, maybe just try to minimize this a bit, because previously it was working. You see, Ahmed, Oracle stuff is not compatible with Zoom, right? That's what I told you. Okay, let's see.
So product
Matteo,
development, can you give us
again,
Zoom licenses? Sorry, man.
Window.
You can just say share full screen.
Share.
Okay.
Yeah, okay, maybe we stick to this one.
Okay.
Yeah.
If it's not a problem, we can stick to this one. Okay.
So how is it? I think it's good, Ahmed, right? We can carry on.
Yeah, no, it's fine. Yeah. I mean, you know, we're not going to.
If the size is acceptable, I can start.
Yeah.
Yes, you can start. You can start. It's fine. Thank you.
Right on time.
It's getting better?
Yeah, it's getting much better.
Okay.
And it stops there. Yeah, I think stop there. Yeah, it's fine.
Okay, perfect. So I am Matteo Malvezzi. I'm working in Rockpack team with Kavi, and I'm also part of the developers team of the Oracle Database Operator. So Oracle Database Operator is composed by different controllers, and I'm in charge of the development of a multi-tenant controller. So in this presentation, you will see a quick review about the operator, okay, and all the controller, not all the controllers, but the most important controllers in the operator. So if you have any questions about the other controller, okay, and you want to dive into the details, I can connect to the right developer of the controllers. Okay. Anyway, as I said, I'm working on the developing of the multi-tenant controller. Okay, and let's say it's a product that keeps on growing. So because of that, okay, if you have any idea or any announcement request that you want to propose something that you that think that can be improved, please feel free to ping me or Kavi, okay, with your and share your ideas. Okay, so in the agenda we have the Oracle database operator for Kubernetes. As I said, a quick overview, okay, and we can talk about the pluggable database lifecycle management and OKE cluster setup. Now we are using ORS, okay, inside the pluggable database lifecycle management controller. ORS is, I guess it's, I guess you know it very well because it's in fashion, and everybody knows ORS. Okay, ORS does a lot of stuff, but okay, we use ORS exclusive only for pluggable lifecycle management. Okay, so the controller is not intended for all the other functionalities that ORS can provide. Okay, and then I will show you the configuration, okay, the controller configuration, and the lifecycle management and the controller utilization. So I want to make another clear statement. In this presentation, we are using two different controller, okay, to do the PDB lifecycle management, and we don't have the namespace segregation, okay, but okay, and of course it's a limitation, but okay, namespace segregation is on the way. So in the next release you will find this new feature. Okay, Oracle Database Operator is an open source, so you can go to GitHub, grab the code, and then you can compile, or you can also mess around with the code and do your experiment. The database operator is written in Golang, okay? And I don't know if whether or not you are familiar with Golang, but it's not difficult to understand. Okay. The concept behind the operator, okay, is the reconciliation loop. Okay, so the operator is a bunch of entities, okay, to monitor, okay, and to keep into let's say a desired state, okay. If they diverge from the desired state, okay, the operator, to be precise, the controller tries to bring back the resource in the desired state. Okay. Okay. We have a controller. So for PDB lifecycle management, we are working on DBCS, sharding, autonomous, and single instance. And oh, sorry, there is a repetition here. And rack controller is on the way. In the next release, we will have also the rack controller. Okay, let's sorry. As I said, operator, okay, can be installed on premises and in Oracle Cloud Infrastructure. Okay, you have the OKE cluster. Okay, you can install on the OKE cluster. And another important thing, I think that it's not mentioned here, is the fact that except for multi-tenant lifecycle management, all these entities, okay, single instance, autonomous sharding, and so on, so on, so on, are running on the Kubernetes cluster. Okay, multi-tenant PDB lifecycle management, okay, operator can manage database on premises, on cloud, or on Kubernetes cluster itself. So, bottom line, these are entities that runs on the Kubernetes cluster, but in case of multi-tenant operator, the resource can be anywhere. How does it work? Okay, as I said, we have Kubernetes cluster, and we create a pod, which runs which run ORT. So ORT connects directly to the database. Okay, and the CRD associated to pluggable database talk to ORT using HTTPS. Okay, we do not support HTTP. We have decided not to have two branches, and okay, basically we get rid of HTTP. And it's not okay. This slide should be improved. It's not mentioned here. It's not, sorry, it's not shown here. But okay, the important thing is that with namespace segregation, okay, people who are in charge to deploy pluggable database cannot access to the container database, because only the ORD service can access directly via SQLnet to the container database. So you may ask what's the reason of this architecture. Is because we want to let's say give the possibility to developers to deploy the pluggable database along the microservices. So everything can be done using kubectl. Okay, you deploy microservices, and along with microservices, you can deploy also the pluggable database without having any credential of the container database. So, as I said, we simplify the deploy, okay, and okay, and we don't we don't need, of course, a physical database for each microservices. Okay, so basically we can have a one-to-one relationship between microservices or one-to-many between microservices and pluggable database. This is the controller overview. Okay, we have the API layer. We have the, sorry, this is the architecture overview. Sorry. We have the API layer. We have the microservices. Okay, and we have the PDB pluggable database relationship one-to-one with microservices. Okay, this is the general architecture. I don't remember if I have included also the slide with the operation that it's possible to perform, but in any case, I will recap at the end of the presentation. Okay, let's see. Let's see in the details the macro steps we need to implement. Okay. Okay. First of all, we need obviously a Kubernetes cluster. Okay, and we work with OKE, of course, because we have Oracle Cloud and OKE. It's easy to deploy, and okay, it's not mentioned here, but I prepare most note where you can deploy OKE with a single script. You and okay, if you need it, just ping me, and I will be happy to send you the number. Okay, and with this script, you just need to specify the name of the cluster, the VCN that you want to use, and you will have OKE in 10 minutes. Okay, and you can also install the operator on the OLCNE and or on premises on other cloud vendors. So we had a wide range of possibility in terms of Kubernetes cluster. Okay, we can say that from this point of view, we have there are no limitations where you can install the operator. Okay, we will see how to configure the database operator, how to configure ORs for Kubernetes cluster, and then just as an example of PDB creation. Okay. If you decide to okay, in this, of course, in this example, I will present OKE. If you decide to choose manual cluster configuration, mind that you have to set up the security list, in order to let OKE cluster talk to the other to the other nodes, to the other objects that you have in your tenancy. Okay, and regarding your client, of course, you have to install OCCLI, and once you have installed OCCLI, you have just to configure kubectl. Okay, and this is not a big deal. You have just to follow this path, grab the script, copy and paste on your client, and you are done. Okay, and then you can install the Oracle database operator from your client, you have to pull the images from our registry, or if you want to to dive in more details, you can compile the operator. Okay, but basically the shortest path is pull the image from the Oracle registry, Oracle container registry. So you have these two options. Okay, and these are the technical steps. Okay, from your client, you have to apply to install the cert manager to manage certificates, TLS, and so on. Okay, you can apply the operator YAML file. Okay, and in less than a minute, you will have the 3 pods running the operator. Okay, remember that please remember that I'm not using here in this slide namespace segregation, but it's on the way. Okay. So this is method number 1. You can set up the operator by downloading from the registry. Method number 2, you can compile. Okay, just download from GitHub, and you need the Golang compiler. And okay, sorry, there is a missing item. You need also Kube Builder. Sorry, forgot to add this item. Okay, and just then follow the instruction, and in the directory of the project you will find a makefile. And by executing these targets, okay, these are the targets that you have in the makefile. You will compile the operator on your machine. Okay. As I said, we have the PDB lifecycle management in the operator by using 2 controllers, because we have 1 controller for the REST server ports and 1 controller for pluggable databases. Okay, and okay, we are going to simplify. We are going to simplify these steps. Okay, because we have to build the image, push the image on your registry, and start the CDB resource. In this case, we have a one-to-one relationship between CDB and CDB resource on the Kubernetes cluster and the container. Please mind that you have to do this step. We have a couple of customers that tried to avoid this part and download directly OR's image that you find on Oracle Cluster Registry, and they're doing wrong, because the OR's image that you find in the Cluster Registry is designed to do to use all the ORS functionality. And you have to do this step because you create an image dedicated to Kubernetes and to PDB lifecycle management. Okay, so avoid this step is not an option. Okay, and you have to configure the secrets. Okay, so you have to create secrets for passwords, CDB passwords. Okay, and they are base64 encoded. And you have to create certificate to guarantee HTTP protocols. Okay, at this stage we can create the ORS services. The pod, to be precise, the pod which runs the ORS services, and you can see here the information that you have to specify in the YAML file. Please note that we decided to abandon the old syntax, hostname, port, and seed or services, because we want a general TMS URL, which allows you to specify, for example, a data guard architecture. Okay, we don't want to stick around only to one single instance running on a single node. Okay, but we want to use rack. We want to use rack in a data guard ecosystem. So we have decided to use the DBTNS URL instead of hostname, port, and service or seed. Okay, and after we apply the STB file, we will have also the pod for the ORS for CDB. Okay, you can check the log, and then we can get the status of the CDB to see if it's up and running. Okay, I've cut the TNS alias just to fit into the slide. Okay, and you can describe the resource. You have also the possibility to connect to the ORS to do some debugging. Okay, and this is the part of the run shell that we execute into the images of the ORS controller. Okay, and now we can create the PDB. Okay, so PDB is managed. PDB CRD, okay, which stands for Customer Resource Definition, is defined. Is managed by another operator. By another controller, and we have, of course, the association one-to-one between PDB CRD and the pluggable database. We have the specification loop that keeps track of every change, every divergence that we have between PDB and the desired status described in CRD. Okay, you can see the definition of the PDB CRD in this pattern, this code pattern. Okay, but this is just for the sake of your curiosity. It's not part of the let's say day-by-day activities. Just to this slide is just to understand the logic. Okay, and now we have the PDB creation. We have just to apply PDB on file. Okay, and you will have in a couple of minutes the pluggable database up and running into the container database. You can check the log of the controller using this syntax. You can check the events and okay. This is the structure of the YAML file that you are using to create PDB. Okay, and these are the operation that that we can execute using our controller. Our controller, sorry, because remember we have two controllers to manage pluggable database. Okay, we have just for clarification, if you do not the mistake to do the kubectl delete, okay, just because in this case we delete the CRD, but we not delete the pluggable database. Okay, and if you want to delete both, you have to specify in the YAML file that we have a specific delete calls. Okay, we can open, as I said, open and close the database, and we have plug and unplug. Okay. And you can find here the example of the plug and unplug. Okay, forget about this for a while because ORDs no longer support plug and unplug database with TDE if the ORD server and the database are not running on the same machine, which is not our case because ORDs run alone in a pod of Kubernetes cluster. So for the moment, this option is no longer available, but okay, we are working to find an alternative, but at the moment it's not feasible. Other operation, an interesting operation is the synchronization. Assume that you have by mistake or whatever reason, someone creates directly a pluggable database. Of course, you don't have its counterpart in the CRD list. And so, if you want to manage this new arrive with Kubernetes, you need the CRD associated to the pluggable database, and you have this capability by using the synchronization command. And okay, this is another important command. Okay, you have the capability to deploy a new version of the controller without reinstalling everything. Okay, so assume that you have a new version of the operator. You don't have to reconfigure and all the all the CRD associated to the pluggable database, synchronize, etc. Just use this command and you are okay. And I think that I finished right on time. Okay, that's all from my side.
Cool. Thank you, Matteo. Ahmed,
Okay.
I still don't see much in the chat. There's no questions. So if there's anything, please revert back to us and let us know how we can help you. Even if you're
Sure.
interested.
Thank you, man. Sorry, we just ran out. Can you upload the presentations for us onto the chat? That's about it. And if there's any questions, our team can then email me the questions and I will forward it through to you.
Sure.
So thank you, Matteo and Corrado, for your time and for explaining to us the products that the development are working on. To the team who are available on the chat, I know we're running out of time, but please do connect via LinkedIn to Kavi, Matteo, and Corrado. Thank you very much, and that's all. I'll close the session. Thank you very much.
Thank you. Bye-bye.
Thank you, guys.